Hello, my name is Omar Alexander Gonzalez Benitez, and I am a staff research associate at the UC Davis Strawberry Breeding Program. Today I'll be talking to you about our Anthracnose trial, where we screened 105 cultivars in elite breeding lines in the span of 2 years. I first would like to say that I am currently a UC Davis employee, but all this research was done when I was doing my master's with the Cal Poly Strawberry Center. And the overview of my presentation is I'll introduce Anthracnose, I'll then go over the objective of this experiment, I'll do materials and methods and how we got our ratings, our results, and then our conclusion. Anthracnose is caused by Calototricum occultatum. Anthracnose is an economically important disease because when present, it can cause high plant mortality. Anthracnose has a broad range of hosts. This includes almond, apple, pines, and some weeds. Some symptoms that characterize anthracnose are necrotic and blight symptoms on plant leaves, petioles, flower, or even roots. Now this is seen by image number 1, where you can see the necrotic and plant collapse, eventually leading to the death of the strawberry plant. Anthracnose also causes fruit lesions on ripe fruit. You can see this on image number 2 and number 3. The image number 4 shows the fruit lesion zoomed in where it shows the anthracnose spores. Other symptoms that characterize anthracnose are dark brown and black sunken lesions on petioles and runners. Now in all these 3 images, you can see a set of petioles and runners that are infected and with sunken lesions and some necrotic spots. During the 2015 and 2016 strawberry season, there was an anthracnose outbreak leading to high levels of anthracnose in fields. This occurred in the Santa Maria and Knoxtown area. Now in the image in the right, you can see a field with anthracnose symptoms. Because of this outbreak, it led to this experiment and the objective of studying 105 cultivars in elite breeding lines and screening them against anthracnose. Our materials and methods. This experiment was conducted at California Polytechnic State University in San Luis Obispo. In year 1, the trial was conducted at Field 25, Block 3, as shown by the arrow. The trial initiated October 23rd of 2018 and was terminated on April 29 of 2019. For year number 2, this experiment was conducted at Field 25, Block 8, as shown by the second arrow. The trial initiated October 23rd of 2019 and the trial terminated on April 29 of 2020. The experiment layout was a complete randomized block design. In year 1, we had a total of 76 cultivars, and in year 2, we had a total of 59 cultivars. Now there were a total of 30 cultivars that were used in both years. Each cultivar consisted of 4 inoculated reps and 1 non-inoculated rep. Each rep had a total of 10 plants. Now for inoculation method, there was a total of 3 local isolates of anthracnose used. Now in image number 1, you can see anthracnose growing in lab on media. Image number 2 shows the aftermath of when we harvested spores for the inoculum. Bare root transplants were soaked for 1 minute in 100 milliliters of anthracnose inoculum. Here in this video, you can see us pouring the inoculum into the bags, and then we seal and shake the bags for 1 minute. We make sure that all the plants get soaked in the inoculum, and then soon after that the plants are soaked, we then take them into the field, and once in the field, we set them into its designated rep and plant. Our ratings occurred in a weekly event. We took plant mortality assessments where we counted the number of dead plants in each plot. From there, we got percent mortality. The picture on the left shows high percent mortality. The picture in the middle shows medium percent mortality. And the picture on the right shows low percent mortality. Here's a video showing our plot layout. This video was taken in July of this year, and it shows the experiment. You can see some of the cultivars that are susceptible and some that are resistant to the anthracnose. You can see some susceptible cultivars with high plant mortality and some with low plant mortality as well. Now our results, we had first symptoms of anthracnose 3 weeks right after planting, and that's when we started taking plant mortality assessments. Now, the majority of the plant death occurred by January in both of the experiments. The breeding programs that were involved in this experiment were University of Florida, University of California, Davis, Plant Sciences, Planasa, Lassen Canyon, and Driscoll's. Now here I am showing you plant mortality in year 1. Plant mortality is on the x-axis, and on the y-axis you can see the cultivar and elite breeding lines. Here I'm just showing you how in each breeding program there was a wide range of susceptibility and resistance to anthracnose. With the arrow, I am pointing at Monterey, a cultivar that is widely used in the industry. It is close to 100% mortality. Now you can see that some of the programs had 100% mortality, and there were some of the programs like Plant Sciences that had a 0% mortality cultivars. Here I am showing you the data for year 2. In the x-axis, you can see plant mortality, and in the y-axis, you can see the cultivar and elite breeding lines. Again, in all the breeding programs here, you can see that the susceptibility and resistance among all cultivars had a big range. In this year, Planasa did not participate in the experiment. Now I'm highlighting cultivar Monterey, and you can see that it's at 100% plant mortality. Now this year, there was no cases where any cultivars had 0% plant mortality. I am now showing you the 2-year data of the 30 cultivars that were in both years. Here you can see the black graph shows the 2018-2019 season, and then the gray graph shows the 2019 and 2020 season. You can see cultivars like Victor and Monterey that are right at the very top with high percent mortality show the cultivars had very similar results in both years. But then you see cultivars like Del Rey, which is a third down of the y-axis, or others like Ruby June, which is a third from the bottom of the x-axis. You can see that they have over 50% difference in both years. This is important because it shows that it's important for a breeding program to conduct experiments more than 2 years. Now for management practices, first I'll go over pre-plant. It is important for nurseries to use good sanitation practices because this can lead to using disease-free plants. Other ways that you can manage anthracnose is by fungicide dips immediately prior to planting. Now the number one way to manage anthracnose is by using host plant resistant cultivars. After planting, if anthracnose is in your field, the best way to manage it is by avoiding using overhead irrigation. This is important because the anthracnose spores love to spread through irrigation. Another thing is practicing good field sanitation practices. This includes removing weeds, infected plant material, and infected fruit. It's important to remove them because through irrigation they can spread easily if those plant material are infected and in the furrows. Another thing to do is IPM and scout fields. This can help you identify any hotspots in the field, and then you can accurately provide foliar application of fungicides to help minimize anthracnose spread. Thank you.